Hey everyone, and welcome back to the Academia Research Collective. My name is Darren, and today on Research Bites, we will be talking about control groups. Now, control groups are a necessary part of any experiment, and so let's get straight into it. First of all, what is it? Well, a control group is the baseline of the experiment. It's something that is static and it does not change, and basically what you're trying to do is to see what would happen if you did not have your variable. What this means, and what I mean by variable, is the thing that you're actually testing. The easiest way to explain this is with an example. Let's say that I had a plant, and I was trying to see what would happen if this plant grew in sunlight. I was trying to see the effect of sunlight on this plant. Well, I would have a control group of a plant that was not in the sunlight, and then also a plant that was in the sunlight. That way I could compare the two, right? I could compare the plant that was by the sunlight and see how sunlight affected the plant in comparison to my control group, which was the plant that was not in the sunlight. Otherwise, I wouldn't be able to actually tell if my plant in the sun grew better or not if I didn't have something to compare it to. And so that's why I need a control group. And so, once again, why? It's because of validation, right? Without a control group, you can't tell if the change is from your variable, which is the thing you're testing, or some kind of random chance. The plant that grew better in the sunlight might have been because it just happened to grow better. Maybe it's because of the environment, maybe because of the water, or it could actually be because of the sunlight. But I need something to compare it against being in the sunlight, which would be not being in the sunlight, which is why I have a control group. Basically, we're just trying to see how effective is your method or your invention. Is your invention actually improving something? Is your method actually improving something? Or is your method actually working? That's why we have a control group. So our first example is in psychology. Let's say a company called Snoozies came out with a new pill that was supposed to help people sleep better. Well, in order to actually test whether it works, I would need to get a group of large participants, and then I would either give them the Snoozies pill or a control pill. Now, the control pill is just a pill that looks like a pill. There's nothing actually inside. It's just a pill. But the participants don't know which pill they've been given. After 7 weeks, I would ask the people who I know took the Snoozies pill, hey, did you sleep better? And if they say that they slept better, that's great. But then I'll compare this to the control group, and I would ask the control people, hey, did you sleep better or worse? And let's say on average, the Snoozies people did sleep better than the control group. Well, then that probably means that the Snoozies pill actually works. But if the Snoozies people slept the same as the control people, then that probably means that Snoozies doesn't work, because a pill that had nothing in it had the same improvement in sleep quality as the Snoozies pill. And the control also suggests something known as the placebo effect. The placebo effect is basically where just someone believes something good has happened to them based on something in their environment. What I mean is that the people don't know whether they have a Snoozies pill or the control pill. So they just might think, oh well, I'm taking this pill, my sleep will probably get better, and then psychologically their sleep actually got better. But this doesn't prove anything, right? The control pill and the Snoozies pill both rendered an increase in sleep quality, which probably means that the Snoozies pill was not very effective. And so that's an example in psychology where a control group is necessary. Now, a second example is in computer science. And usually in engineering computer science, the control group is the baseline to which you're comparing something to see if a new algorithm or a new design is better than the original. What I mean is that, let's see here. Let's say I had 2 algorithms that were trying to compress files as quick as possible. I have the control, which is the original program, and I have a new program, which I'm testing. And let's say I timed how fast they, compressed files. Well, if my new program compressed in 20 seconds, but the original program compressed in 30 seconds, then I could say that my new program was an improvement. But the reason we need a control is, let's say I didn't have the control and I just had my new program. Okay, my new program compresses the files in 20 seconds, but is that better? Is that worse? Is it the same? I don't know. And so that's why I have a control. And lastly, in biology, let's say I was trying to test this new invention called superfood that was supposed to help this bacteria grow significantly bigger. Well, to test it, I would need a control food and I would need superfood. And let's say I gave the control food to the bacteria and the bacteria grew 5%. But when I gave it superfood, it grew 15%. Well, then that's probably an example of where superfood is actually working, because compared to the control, the usual food that we give bacteria, it grew significantly faster. But let's say both the control and the superfood grew at the exact same rate, or the superfood is worse than the original. Well, that's probably showing us that superfood isn't working. And so that's an example in biology. So yeah, that's it. That was the control group. Hopefully by the end of this, you'll have a pretty good idea of what a control group is, why it's necessary, and how you should be able to apply it into your research, because without it, you will not be able to validate your results. Thank you very much for watching Research Bites and the Academia Research Collective, and I'll see you next time.